Have you ever stopped to think about our wireless world? It is just jam-packed. Your phone, your watch, your laptop, your car, everything is constantly sending and receiving signals. So how is it not just a complete and utter chaotic mess? Well, today, we're going to pull back the curtain on the incredibly clever trick that makes it all work. I mean, seriously, just picture it. If you were in a packed stadium and everyone tried to shout at the exact same time, all you'd hear is a giant, meaningless roar. So why doesn't that happen with our data? That's the big question we're tackling in this explainer. And the answer, well, it's pretty brilliant and not at all what you'd expect. So before we can get to the solution, we've got to really appreciate the scale of the problem. Let's think of our wireless world as one gigantic, crowded room, a conversation where every single device is trying to get a word in edgewise. For decades, the logic here was pretty simple. If you don't want people talking over each other, you have to separate them. You either tell one person to talk, then the next, and so on. That's like giving everyone their own little time slot. Or you put them in different rooms to have their private chats. That's like giving them their own frequency. The golden rule was simple: avoid interference at all costs. And this whole idea, this philosophy of strict separation, it was the bedrock of everything from old school radio all the way up to 4G networks. And look, it worked. But as you're about to see, it was also becoming a massive bottleneck. And this right here shows you the huge shift in thinking. On the left, you've got the old way, technologies like OFDMA, which would carefully slice up the airwaves and give everyone their own little piece. But on the right, that's NOMA. It's this wild, radical new idea. Instead of running from the chaos, NOMA just dives right in. It basically says, you know what, everybody talk at once. We'll sort it out. Okay, so how on earth do you sort it out? That brings us to the real secret, the core trick behind NOMA. It's not about time and it's not about frequency. It's all about a totally different dimension we haven't even talked about yet: power. And this is the key. NOMA, which stands for Non-Orthogonal Multiple Access, lets a bunch of different signals pile into the exact same space at the same time. The way it tells them apart is by intentionally making one signal way louder, or technically more powerful, than the others. They're separated in what engineers call the power domain. This quote is the perfect analogy. It makes the whole thing click. Just imagine that exact scenario for a second. You've got two completely different sounds coming at you at the same time, but your brain can handle it. It can process both. How does it do that? Your brain is amazing. It does this completely on its own. First, it hones in on the most dominant sound, that loud shout. You can't miss it. But once your brain has identified that signal, it can kind of filter it out, subtract it, which lets you then focus on and actually hear that much, much quieter whisper. You're literally performing interference cancellation right inside your own head. Okay, so our brains are pretty incredible. But how does a phone, a piece of metal and silicon, pull off that same amazing trick? Let's take that analogy and see how it becomes real technology. So what your brain does instinctively, your phone does with a specific algorithm. It's called Successive Interference Cancellation, or SIC for short. And it's the exact same logic we just talked about. Listen for the loudest thing first, figure out what it is, remove it from the mix, and then listen for what's left behind. So let's say you're standing right next to a cell tower. That makes you a strong user. Your phone gets this jumble of signals. First, it locks onto that really high power signal, the one that's actually meant for someone else who's far away. Then, using SIC, it digitally subtracts that loud voice. And what's left underneath? Its own lower power signal, which it can now decode perfectly. Now, this is where it gets really wild. The cell tower does something that feels completely backwards. It actually gives more power to the weak user, the person who's farther away and has a shaky connection. And it gives less power to you, the strong user who's right nearby. Why would it do that? Well, it's to make sure that faraway signal is the loudest thing in the mix, so that everyone can hear it and subtract it first. So let's just pause on that for a second. Your phone, the strong user, gets both signals at once. Based on what we just said, which signal does it go after first? The signal meant for it, or the signal meant for that person far away? And there it is. That's the big aha moment. It decodes the weak user's signal first for one simple reason. The cell tower made it the strongest signal by pumping 70% of the power into it. Your phone has to peel back that loud outer layer to get to the quieter signal that was meant for it all along. It's just a beautiful, elegant system. Okay, so that's a seriously cool piece of engineering, but why should we really care? What's the actual real-world benefit of embracing all this managed chaos instead of demanding that everything be neat and tidy? while the payoff is just massive. To put it simply, if an older method could support, let's say, 100 devices on a certain amount of bandwidth, NOMA can support 250 on the exact same bandwidth. By letting everyone share, you massively increase the capacity of the whole network. More devices, more connections, all without needing to find more airwaves. And the good news just keeps rolling in. This huge capacity makes it absolutely perfect for the Internet of Things. Think of connecting thousands of tiny sensors or smart meters that only need to send a little bit of data. It uses our precious, limited spectrum way more efficiently. It's even fairer because it helps make sure that users with a bad signal still get really good service. This is exactly why NOMA is a cornerstone technology for 5G and why it's a huge deal for the 6G networks of the future. Ultimately, NOMA teaches us this really powerful lesson. Sometimes the best way to solve a traffic jam isn't to build more roads, but to learn how to listen more intelligently on the roads we already have. And it really makes you wonder, what other impossible problems are out there just waiting for us to solve them by breaking the old rules?